These are the 6 indicators that the NRCS has standardized under CEMA 216. Each one is measuring something specific about your soil, and together they give you a picture of how your soil functions as a living system. The first indicator is soil organic carbon. This is the anchor indicator. Soil organic carbon tells you the total amount of carbon stored in your soil, not just the active fraction, not the stable humus, everything. The dry combustion method to get this indicator value heats your sample to around 900 degrees Celsius and measures the CO2 released. It's the most accurate method we have for total carbon. But why does the NRCS lead with this indicator? Because soil organic carbon is the single best integrator of soil health. It directly drives water holding capacity, nutrient cycling, microbial habitat, and aggregate stability. When organic carbon goes up, almost everything else follows. When it goes down, the soil loses function. For the regenerative pilot specifically, organic carbon is the indicator that tells the NRCS whether your system is building or depleting. A 5-year CSP contract that shows a measurable increase in soil organic carbon is the strongest possible proof that the practices are working. It's the number that anchors this whole assessment. The second indicator is wet macro aggregate stability. This is the physical structure indicator. Wet macro aggregate stability measures how well your soil holds together when it gets wet. The test takes a dry soil sample, places it on a sieve, submerges it in water, and the percentage of soil that remains intact as water-stable aggregates is your score. This matters for 2 reasons that go way beyond the lab. First, aggregate stability is the primary control of water infiltration. Soils with strong aggregates absorb rainfall, and soils with weak aggregates seal over and shed water as runoff. If you're in a watershed program or anywhere near a drinking water source, this is the indicator that connects your field to downstream water quality. Second, aggregate stability responds directly to tillage and biological activity. Fungal hyphae and root exudates are what glue aggregates together. When you reduce tillage and increase living roots through cover crops, aggregate stability improves. So this indicator is a direct readout of whether your physical management is building or taking away your soil's structure. For operations in the Southeast, where we are, where heavy clay soils and intense rainfall are the norm, aggregate stability is arguably the most important operationally relevant indicator on this list. A high score means your soil is handling rain events. A low score means you're losing topsoil every time it storms.